So welcome back. And we just talked about in the previous sort of part of this lecture, we talked about the big picture of resilience and how we can build resilience into the planning processes. And now we're talking about engineering resilience and with respect to a piece of infrastructure and how we can assess benefit, cost, and financial feasibility of projects that are designed to improve airport resilience to the impacts of climate change and extreme weather events. And what we want to do is we're trying to explicitly account for risk and uncertainties that are inherent in the long-term climate projections. Obviously, no one knows precisely what's going to happen in the future, and that's why the risk and uncertainties need to be accounted for. And this also relates with the previous lecture that we had about different scenarios. And now what I'm trying to do is I'm trying to give you a real world scenarios as to what kind of risk and how we can incorporate risk into this long term. So you can think of this as a more real world example and a more specific example of the last two things we talked about in our lecture. One was the decision under uncertainty that we discussed the week before Thanksgiving. And then what I just discussed just now about climate change and resilience. The methodology here is also broadly applicable to any uncertain financial or economic matter being considered by the airport. So you could extend this methodology to ridership projections, for example, and things like that. So climate change impact in the coastal region, there is potential for extreme flooding due to storm surge and sea level rise. And then in warm and high climates and high elevation areas, the potential for rising temperatures that will require weight restrictions on airport takeoffs. It's like if the temperature is high, the airport runway might become, might become susceptible to higher weight. And then you might have to wait for the the runway to cool off, so that it still remains hard enough for high weight restrictions. So that could lead to, and then lower the air density, faster the airplane must travel to produce enough lift to take off. So there could be, so climate change could have impact in the coastal region as well as in the warmer climates with high elevations. You could have weight restrictions during takeoff. So this is just to focus the discussion so that we cover the broader areas of concerns from the climate change, because these two have the most economic impact. Because if you have to shut down the runway, that'll have huge economic impacts. And then also, if you have to delay the flights because you cannot run the full flight because of high temperatures, and that's a problem as well. So, and you could kind of go back and take this step 1 and step 2. You can see that this is also relevant to the risk and resilience framework that I showed you earlier. So if you're going to go back, I hope you can see the analogy between what I'm showing you for the specific example, and then you could see that analogy from the risk and resilience analysis framework that I showed you earlier. So I hope you can connect this slide with this one, which basically trying to do the same thing, is that you're trying to screen for vulnerable and critical infrastructure. Okay, so you look at the cost to the airport, and then you look at the likelihood of that scenario happening. And then your basic risk calculation is that if you move towards the top right of this chart, you have cost is high and then likelihood is high. So that's where your resilience focus ought to be, because that's going to cost you the most and it's the most chance of occurring. But if something is going to be, because some things might have very high cost, but very low likelihood, so then those things will sort of fall under the medium risk. So that could be a medium priority. And then if something has low chance of happening and low risk, low cost to the airport, then that would be a low under the priority scenario. Estimate outcome with the worst case across climate projection. So ACI, so this is the project. So the across has a resilience. So it's airport climate resilience operation scenarios, I believe, and that you can find in the spreadsheet that I'm going to share with you. So you look at the worst case climate projection, and then if you look at, if you're in that scenario where you have certain scenarios that have this high, that fall under this high risk scenario, then you look at, okay, is the further analysis warranted? If it's not warranted, then you stop. But then if it is warranted, then you look at, assemble the latest climate projection, develop sampling plan to incorporate the uncertainties, and then you incorporate like very high number of scenarios, like 5,000 different scenarios. And then for all of those scenarios, look at how the mitigation would pay off. Okay, what are the chances of very large losses? And then you look at the mitigation assumptions, you feed that into those scenarios. And then essentially what you're doing is you're running a probabilistic analysis where you randomly associate, evaluate very large number of scenarios so that you can see the percentage of time you are running the risk of very high cost. Okay, and then based on that, you can make a decision: can you live with that risk? If you can't, then you make improvements. If you can live with that risk, then you don't make an improvement. So this is this evaluation of many scenarios that is related to the Monte Carlo simulation. That's what we call the Monte Carlo simulation approach, and we're gonna talk about that. So here are some example intervention or investments. You can, if you're talking about the runway flooding, you can enlarge the stormwater system. You may want to know the likelihood of stormwater rising above critical levels. And then runway extensions to offset payload penalties. How many days per year temperature will exceed critical levels that will cause airlines to offload the payload on long haul flights? So if how many days would they have to do that? So they can, those payload penalties that the airlines will have to pay, you can figure out how much the runway extension cost in relation to those payload penalties. Because if your plane cannot run full because the temperature is too high, then they will have to sort of offload some of the cargo or people, and then those people will have to be compensated, and those cargoes that are being delayed, that airlines will have to pay a fees for that. And you can look at those costs and balance out, what's the cost of the runway extension? Can I justify my cost? But the uncertainty is how many days per year the temperature would exceed. And we don't know that for sure, but we can figure out probabilistically if this, what's the chances of happening certain things happening, and we can evaluate it in that context. So in the Monte Carlo framework, investment decision-making under uncertainty can be computed in a Monte Carlo framework where many what-if simulations are considered. So what if this happened? What if this happened? What if that happened? And randomly sampled for different climate projection to capture variation. So this is very important, that to capture the variation in the potential outcomes. Each simulation results in an outcome of benefits and costs under both baseline and the scenario. So baseline would be no mitigation project, and scenario with the mitigation project. And then outcomes from Monte Carlo simulation can be analyzed with a value at risk analysis that sorts the results by probability of best case scenario to the worst case scenario. Okay. And again, you don't have to worry about this slide because I'm going to give you an exact thing of how to use that spreadsheet. And this is sort of the example results. So in example results, and again, I'm going to talk about this in a spreadsheet in just a second, but this is the type of outcome that you can generate. So distribution of possible outcome values at risk. So this blue one is the baseline NPV, net present value, without the project. Okay, so basically, if there is a 0% chance, or very low chance of flooding, for example, okay, if there is a very low chance of flooding happening, then then you could, so for example, if the airport does nothing, scenario, this is going to be your net present value under that scenario. And then you're evaluating that value under different risk projections. And basically based on this chart, I'm looking at, there is a 20% chance of, you're basically figuring out under each scenario, what is going to be the net present value at 0% risk, 10%, 20%, 30%, and so on and so forth. So if you look at, if you don't do anything, there is about a 20% chance that you're going to lose your net present worth of do nothing scenario is negative 40 million. And there is a 20% chance of that happening, because under 20% of the scenarios, your net present value of do nothing scenario is more than 40 million. Okay. So my question to you here that I want to ask you, looking at this chart, what is the chances of airport losing more than $30 million? What is the chance of the airport losing more than $30 million based on this chart? I can tell about 20% chance of losing 40 million or more, but my question, that's on the chart. But what I'm looking for from you is, what is the chance of airport losing more than $30 million under the do nothing scenario? Okay, I'm going to go ahead and pause the recording. So what I'll do for that is that I'm going to go ahead and draw approximately a $30 million. I should probably use a different color here. So I'm going to draw a line at about $30 million, and I'll see where it intersects the blue line, and I want to project that point back upward. So if you look at this, there is about a 45% chance that the airport would lose $30 million under the do nothing scenario. Okay. Now, so if you go back, so there is a 45% chance. So I can figure out a different dollar losses. And what's the chance that the airport loses $60 million? That chance is pretty low. So if you look at the $60 million scenario, that chance is probably only like maybe 1 or 2%. Okay. So here, based on this, you can decide what are your chances of losing a certain amount under the do nothing scenario. Okay. But the net present worth of doing something, is represented by this other curve, the sort of the red curve. And under that scenario, you're seeing that chart over here, and you can figure out there is about a 75% chance, or there's about a 70% chance that the net present value of the project scenario exceeds the net present value of doing nothing scenario. So there is a 70% chance of the project paying off. But there is a 30% chance that the project doesn't pay, because maybe you build the project based on the stormwater projection, but that flooding never materializes. So in that scenario, those 30% of the chances, you might have been better off not building that infrastructure. But you could see, here is the problem though. You could see that even in the scenario where the project doesn't pay off, this difference is pretty low. So you could see that the difference here is pretty low. The difference between the blue and red line is pretty low on average, right? But if flooding does materialize on the other side, these differences between the average scenarios are fairly large. So even though there is only a 70% chance of paying off, the risk of doing nothing is way large. Okay. And then you could basically, because this is doing it at the different probabilistic scenarios, you can also estimate, instead of just estimating the benefit cost ratio, you can estimate an average benefit cost ratio. And then you can also get a standard deviation of that benefit cost ratio. Okay, so that kind of gets you that uncertainty case as well. And then average net NPV of the project with respect to the do nothing scenario is also positive. And then the standard deviation is though is $8 million. So pretty high benefit cost ratio. So the average cost benefit cost ratio is 1.27. And then you could figure out the risk that the airport authority is willing to take. So with that, so I saw some, around 35 to 40%. So I'm sorry, I didn't see the chat before, but yeah, those questions are about correct. Approximately 35 to 40% is right. I got to about 45%, but that's sort of like, where we were drawing the line. So somewhat, eyeballing that a little bit. So here are the, the results are still, you can do this analysis with that tool, and the tool will give you a full range of potential outcomes. And you still have to make decisions. The decision might still be hard for you, but at least you're now able to look at the full range of outcome. The airport decision makers must essentially decide how much risk from uncertain climate change they're willing to accept. And the methods presented in the handbook, they provide essential quantifiable estimates of the risk. So what I want to do next is I want to quickly provide you with what I have here, what I posted. So if you look at that economics of resilience thing, this lab is due on Wednesday of next week, so there's plenty of time. So I'm asking you a specific question. Report the following items for the extreme water analysis under low emissions and high emission scenarios with D equal to 4%. Okay. And then, you just have to report these numbers. So no report is due. You just have to do the Excel file, Excel work, then I'm going to just show you, and then report the averages, and then approximate likelihood of $15 million in project and do nothing scenarios, and then percentage chance of breaking even with the project scenario. Okay. And here is the spreadsheet that I've provided to you. So here is the extreme water analysis spreadsheet. So you can download this spreadsheet right here. The preview won't show up here, but I'll open that in a second. And then there is a tutorial that I want you to watch that should give you exactly how to do this. And this was developed by the project team that did this. So I can go ahead and play that for you as well. Okay, I know there won't be any sound, but this is about a 20-minute video that you can watch at your time. It kind of gives you how to use that spreadsheet, what they're doing with that spreadsheet, and so forth. So you should get exactly what you need by watching this 20-minute video. And then I want to just quickly show you that spreadsheet as well. The exact mechanics of the spreadsheet would be clear if you watch that 20-minute video that I posted, the MP4 file here. And then I'm going to have to stop sharing and then reshare.